Okay, so in your recap, you're going to flip to question 6.
What pencil? Did you look at green? Okay, yeah.
Okay, so the first part of your test is involving just making equations. Okay, so determine the equation. I have to pick either, this is my formula sheet I'm going to have on my test with me. Do I use factored form or vertex form? Because do I have x-intercepts or do I have the vertex? That's my question. So what would you pick here? Vertex. Okay, so the vertex is 3, -4. And a vertex is an H and a K. Okay, now when I'm using this and finding the A, I need just another point. Sometimes I state the y-intercept, so I need you to pick me a point. Any point on this quadratic we can use. So let's just pick one. Can I pick this top right one? Is that okay with you? 5, 4. Okay, so I just picked any point that I could see. So 5, 4. And a point is the letters x, y. Now I'm going to take all those letters and replace. So this will be 4 equals A bracket, 5 minus 3, because that will go in as opposite, squared, and then a minus 4. That goes in the same. Okay, we all have to remember this step. To do algebra, you have to move that. You have to remember that. That's one of the ones that people often forget. And then can you get me this value all together? What happens there? So I'm going to do 5 subtract 3, which is 2. 2 squared, which is 4. So I have an A value of 2. And a final equation needs to be in that form, except for this time you're going to be leaving the x and y's open. So y equals 2 bracket x, and then what else did we have in there? We had a minus 3 squared and a minus 4. So an equation that tells me the slope and the vertex, but when I graph it, I have a y equals and then something with an x. Some of you on this one might have done a little bit different to get your slope. You might have done an over-up. So for instance, here, I moved over 1 and I moved up 2. It needs to move according to its squared amount. So 1 squared is 1. So it should have moved up 1, but what did I times it by to move it up 2? Okay, same with if I did another pattern here. This moved over 2 and then it moved up 8. Okay, if I move over 2, I have to move over 2 squared, or move up 2 squared, which is 4, but I moved up 8. So therefore, I would also have to multiply by 2. Okay, B, we have x-intercepts and a y-intercept. So therefore, I'm going to use factored form. Okay, same idea. We always have to figure out our a because that's not given to me. Okay, so I'm going to put in my x-intercepts for the r and the s, and they need to go in as opposite because the formula says subtract the value. So if this is a 1, inside the brackets would be a -1 and a +5. Right? Because, for instance, this is kind of what we were doing last unit. The factor x minus 1 has an x-intercept of +1. A y-intercept of -15 is actually the coordinate what? 0, -15, which is an x value and a y value, and now I plug those in. So I replace x with 0, and I replace y with -15. Okay, next, I do the brackets. I'm going to multiply that. So once I divide here, are we okay for me to state that a equals 3? And your final equation will be y equals 3 brackets, and then you have to leave your x, leave your x. So again, in your final equation, rewrite it all with the numbers except x and y are always left open. Okay? Does it make sense? If this is my factor, the x-intercept is 1. If this is my factor, the x-intercept is a -5. Because that's what we did the last half. Okay, C, vertex and another point. So I have a vertex, so I have HK, and I have another point, so I have an XY. Which formula am I picking to use? I'm going to be using vertex form. So you either have x-intercepts or vertex. Okay, so filling in, make sure you fill in properly. So -11 equals A. 2, how do you write the H part in there? This was -2, so you're going to write +2. Okay, -H says write the opposite of your H. Or in math, if you subtract -2, that adds it. So that's what I look like. Okay, again, algebra says we need to get that 5 collected over there. If you're okay, I would like to evaluate that whole thing. So 2 + 2, 4. 4 squared, 16. So an A is -1. And then work to write your final equation. Okay? Okay, word problem number 1. Ida is hitting a golf ball from the top of a hill. The height of the ball is modeled by this expression where h is height in meters and time is in seconds. So there is what my graph would look like with variables, time and height. Okay, go ahead, get your calculator out and type that all in. Okay, I did a Zoom 6. Okay, the height of my ball, I can't really see the top of it. I don't really need a lot of this x here, so let's talk about getting rid of some of that x and moving the y up. So I'm going to go to -3 instead of -10. Y max. What do you want to do? 40 for now? On a scale of 5s? Nope. Didn't go high enough. Okay, window, I'm going to keep trying here. Let's go 60. So close.
What about 80?
80 should do it, I think. Perfect. Okay, let's scratch off what doesn't fit in real life on this graph. So I'm scratching off this y. Time can't be negative. And I'm going to scratch off that because why? The ball can't go under the ground. So there's kind of 3 important points on this graph. Okay, what is the y-intercept? So what I'm going to do is trace 0, enter. My y-intercept is 11.5 meters. What does that represent? The start of what? It would be the starting height of the ball. And where are you starting? You're starting on a hill, right? So I'm writing it's the height of the hill where you hit the ball from. Okay, find the roots of the equation. The same word is find the x-intercepts. So I'm only going to be finding this one because this root is non-existent, right? It's a negative time, it doesn't fit. So we're going to find that x-intercept. So second, calculate a 0. .22. Anybody matches that number? 5.22? 5.22 seconds, right? Because this is the time to hit the ground. So the ball travels, and then 5.22 seconds later, it boom, hits the ground. Okay, domain and range. So in this situation, domain is the time. Our time starts exactly at 0 seconds, and then this situation ends at 5.22 seconds. Okay, I used square brackets because it is exact. Range is the height of the ball. So the lowest height the ball is ever is on the ground. And the highest height the ball is, well, we haven't even done that point yet, so we need that point. So we're going to go calculate, and then this one would be a max. And did we get 71.88? Okay, and I'm not worried about the x part of it, I'm worried about the y part of it, because that's the height part of it. Okay, revenue question. So I want you to give me revenue equals price of the tickets times however many people come. That's how you make revenue. The price of each ticket times the number of tickets slash the number of people. Whatever you want to think of it as. Okay. Revenue equals brackets, brackets. You sell tickets for $10, so price 10. At this price, 500 people come. So put the 10 in there and the 500 in the other one. If you increase the price, so add to the price, be careful here. How do you do 50 cents? Because this was $10. 50 cents. So you can't do just the number 50 in there, right? Because that's different. And do you understand I need an X on there? Because I might increase it by 50 cents or another 50 cents or another 50 cents. I don't know. If you do that, then 10 fewer people come. So if this goes up in price, people will go down. Okay? X's need to be on both of them. Okay, go for your calculator now. Type in exactly as you see it. Okay, let's talk about our variables before I graph it. I haven't graphed it yet because I want to understand my window. X is the number of changes. That's what X is. X is not the price. X is the number of times we change the price. And the Y is the revenue. So on an X, how many times might we change it? let's just do something like well, we can't do negative, so -5 to like, I don't know, I'm just going to go 15 because I don't know. The y is the revenue, so I'm going to just leave the -10 in there, up to, well, let's look at the revenue at the start. $10 times 500 people. At the start, you're making 5,000, and hopefully you're going to go up in revenue. So what do we want to do? 8,000? And I'm going to do a scale of 1,000. I'm going to go every 1,000 up. Okay, so my X prediction was very wrong. Go back to your window. We got to change this X. What do we want now? 50? I'm going to go 50X, and then I'm going to go on a scale of every 5. Yep, I think I like this. Ooh. So close. I might, just making sure I can see that intercept, I'm just going to go to 60 now. It was pretty good. This is good now. Okay. Question A. What ticket price will maximize your revenue? So can you figure out the coordinate that is at the top there, your max? Okay, so that coordinate I got 15, 6,125. Okay, but that's not my answer. What ticket price? So I'm going to do this, 10 plus 50 cents times 15. Okay, so that's the piece you got to remember. X is just not $15. You're going to increase 50 cents, and you're going to do that 15 times. So each ticket would then be $17.50. B, what is the largest revenue? That one we just have on our calculator. That is the largest revenue, 6,125. Okay, question C. What ticket price will it be when the revenue will start to drop below its original revenue? So what is the original revenue? At the very start, how much money did we make? Before we made any adjustments, how much money were we making? We were making $5,000, right? Because $10 for 500 people, we were originally making $5,000. Okay, then we were making changes to our money, which eventually increased our revenue, but then eventually I want to stop because I'd rather just make anything higher. So what I'm going to do is a Y2 line at 5,000. Because really, I'm happy with anything above my original revenue, this doesn't make me as happy, right? Because now my revenue is lower than how I started. So why would I keep changing stuff if I'm making less money? So Y2, 5,000. Graph. Give me an intersection number on that. $30 is the intersection. Is that what we got? We got an intersection at 30. Okay, but not the price. That's not the price. The price is not $30. So we do a what? 10 plus 50-cent increases 30 times. Okay? Please remember that you're going to 100% chance you're having that on your test with revenue. Okay? X is just the changes. X is not the price answer. Okay, number 9. We have a diver that jumps off a 4-meter platform. The diver goes up and then we'll go to the water, right? Okay, can you give me a full coordinate at where the diver is right now, at the start, on the platform? What's the coordinate there? 0, 4. Then, she's going to reach a height of 5.2 meters, 0.19 seconds after leaving. Can you give me a point at the vertex? How are you going to write that? Be careful when you read. Height, time. How are you going to write that, though, as a coordinate? 0.19 is first. Okay. That one can trick people because they're reading it, but the numbers are actually in the switched idea. Okay. So on this one, the strategy is to make an equation. You have to make an equation. So you have this formula sheet. Am I picking factors or vertex? Vertex. Okay. So my vertex, I'm just going to do some labeling here. This is an H, this is a K, this is an X, and this is a Y. Okay, everything is going to get plugged in now. So 4 equals A bracket, 0, then that's the subtract 0.19 squared plus 5.2. Please don't forget your algebra. You're going to have to move the 5.2. Okay, so here is what I did next. 0 subtract 0.19 brackets squared 0.0361. Okay, now I'm doing this, negative 1.2 divided by that answer button, negative 33.24. Okay, all that work, we haven't even gotten to the answer yet. So now my equation will be y equals negative 33.24 x minus 0.19 squared plus 5.2. So that's the place where I just make sure x and y are left open. Okay, now we're ready for our calculator. So everything out, y equals negative 33.24 bracket Okay, before we push the graph button, let's talk about our window. So x is the time. Well, look at this time. This time is 0.19. So what do we want to do on our scale? Maybe just -1 to +1? So each tick is 0.1 seconds I'm going to do because the seconds is very small. And the height of the diver, well, we already know the top height is 5.2. So I'm going to do heights from -5 to 10. That's good enough. I can see it. How long does it take to reach the water? So now that I have it in my calculator, that's what I need to find. Okay, and I can check some other stuff here. I'm just going to quickly go trace 0. Look at that, the 4-meter platform. I'm going to go to 0.19. Look at that, 5.2. I'm up at the top, right? My equation is correct if I'm getting all that. Second, calculate the 0. Okay, so we're looking for the 0 that's a positive. So 0.59 seconds is what my answer is going to be. Okay, last type. We have a circular water fountain, and then it's bordered by a seat. The designer wants the area of the water fountain to be, so this area has to equal this area. The area of the middle will equal the area of the outside. The radius of the whole thing is 14. Okay, so I know from edge right there to the middle is 14. What should the radius of just the water fountain be? So I'm going to do this as an x. The radius of the middle part. I'm just going to call it x because I don't know. Okay, ready? So the area of this inside is going to be pi x squared. How do I do the radius of the surround? Do you remember how to do that? You do the area of the whole thing minus the area of the middle section, and that gets you the surrounding, right? So pi times 14 squared minus pi x squared. Okay? Does that make sense as a strategy? So that's what I was doing. The whole thing minus the middle part gives me the outskirts. Okay, this will be y1, this will be y2. You will find some intersection points. That's the strategy. Okay, I'm just going to be zoom 6ing this, by the way, just to reset stuff. But I want to see higher because I can't see my second one. Sometimes if you have no idea where to go, do we know how to cheat? This is what I do. I go to my table of values, so second graph, and here, looking at my heights, look at these heights. We have heights of like 500, 600, okay? So I'm going to make my y height right now, I'm just going to go to 1,000. Okay, so 1,000 is good on the heights. I need to see wider. So I'm going to go from -20 to 20 to see if that will help. -20 to 20. Oh, I like this. This is good. Okay, so this is the visual I have on my calculator now. And since this is a where do they equal each other, I'm going to be looking for intersection. And why does this intersection not work for us if I wanted to find that one? What's wrong with it? X would be negative, which means my radius would be negative, which doesn't make sense. So I need you just to find me that. So I got 9.90 from an x value there. Okay, that represents what? The radius of the inside. Okay, I just want to talk about one other question I might ask. Here's another question I might have asked this. What is the width of the seat? So the outskirts of the seat, what's the width of this seat? What am I going to do to get that? How do I know that? What would I do to get it? Subtract. Right? Because if we had the whole thing was 14 and this was 9.9, we would subtract. Okay? So just pay attention. That might have been the question. Find the width of the seat. You would do the exact same work, but the end you just have to subtract. So 14 minus 9.9. So the width of the seat would have been 4.1 feet wide. Okay? That's on your test. That's it.